Hello, we are going to continue our conversation about sequences and series. We're moving from arithmetic sequences to geometric sequences and series. And that's when we're multiplying by something. We are not adding or subtracting or adding a common difference. The first question, in addition, we have the formula for the value of r in a quotient. We have the nth term. We have a recursive sequence. So this is our recursive formula. We have our explicit formula. We have the sum of an infinite geometric series and then a sum of a finite geometric series, meaning this one goes to n equals infinity and this is n equals to a fixed number. We're going to start off with question 28 that asks us for the 14th term of the following sequence. So we're trying to find the 14th term. And that's going to help us where we take a to the n, or a sub n is equal to the first a term times the common ratio to the n minus 1. Well, first of all, we have to figure out what the common ratio is. And then we can use our information to help us go from there. How do we go from 5 to 10, and then 10 to 20, and 20 to 40? We're multiplying by 2. So our common ratio is 2 here. We have a, the nth term of a. The first term we know to be 5. That's listed here. The second term, third term, fourth term, and so on. The common ratio is 2. And then if we're using the first term, that's going to be 1 minus 1, which would give us just the first term. But let's say we want something different. Okay. Please be careful and do not multiply 5 times 10. That violates the order of operations. We want to keep them separate. Okay, now we're going to use this information to find the 14th term. The 14th term is given by 5 times 2 to the 14 minus 1. We then have 5 times 2 to the 13th, which is going to be a pretty good sized number. So 2 to the 13th is equal to 8,192. We then multiply that by 5, and we get as our result 40,960. Okay. Moving on to the next question, question number 29. So for the 9th term of the geometric sequence, whose common ratio is 1/2 and whose first term is 4. Again, we use this explicit formula. We're looking for the 9th term, whose common ratio is 1/2 and whose first term is 4. Again, I can't take 4 times 1/2. I have to do the exponent first. The 9th term is equal to 4 times 1/2 to the 8th. Well, that's essentially like 1 to the 8th and 1/2 to the 8th. If you do this in a calculator, you're going to get a decimal. If you really want to know what it is without getting a decimal, you can say the 9th term of a is equal to 4 times 1 to the 8th over 2 to the 8th. 1 to the 8th is 1. 2 to the 8th is 256. The 9th term of a is 4 times 1 over 256. And then reducing 256 by 4, we get 1 over 64. And typically when your answer starts in a fraction, or when your problem starts in a fraction, you want to leave your answer as a fraction. Finally, we're going to be computing some sums. Now, in order to calculate the sum, we're going to use the fact that, first of all, this is a finite series here, as is this, because I'm stopping at 5 and I'm stopping at 9. This tells me I go to n equals 5. This tells me I go to n equals 9. So this is finite. Going up to the next page over here on the right, the sum of a sequence with n terms is given by this formula right here. S sub n is equal to the first a term times 1 minus r to the n over 1 minus r. We need to know the first term, we need to know the common ratio, and we need to know the nth term that we're talking about. Now, for part A, our first term is -2. My nth term is 5. And what's my common difference? Or my common ratio? My common ratio, which is inside where the exponent is -2. That gives us -2, 1 minus -2 to the 5th over 1 minus -2. Following our order of operations, we need to do the exponents first. And think about what -2 to the 5th means. That means -2 times -2 times -2 times -2 times -2. That's an odd number of negatives. That's going to give you a negative answer. My result is then -2 times 1 minus -32 over 1 minus -2. If you're evaluating this in a calculator and you enter the syntax -2 to the 5th, you're going to get -32. If you put it -2 in parentheses to the 5th, you're going to get -32, which is great. This is the right way to enter that. If you did an even number, you would still get a negative when you shouldn't. It should be -2 to the 4th, which is +16. So you have to be careful about your negatives. Simplifying even further, we have -2 times 1 plus 32 over 1 plus 2. That means that the sum is equal to -2 times 33 over 3. And reducing, I'm going to reduce this to make that 11. That's -22 as our answer. On part B, one thing to think about is I need to know what the first term is. You would think that the 5 is your first term, but that's only when your actual term is 1. So for 1, if I plug in 1 here, for the first term, that's 5 times 1/4 to the 1, which is 5 times 1/4, which is 5/4. That means our first term is 5/4. Our n is 9, that's at the top here, and our common ratio is 1/4. Using the formula, we have the first term times 1 minus the common ratio to the nth over 1 minus the common ratio. That gives us 5/4 times 1 minus 1/4 to the 9th over 1 minus 1/4. Now fractions are gnarly. I understand it can be a little bit intimidating, but one thing I will say is that it's important that if your problem is given in fractions, leave your answer in fractions. Doing some math here, I'm going to have 5/4 times 1 minus, that's the same thing as 1 to the 9th over 4 to the 9th, so that I can use my calculator to not get a decimal. Okay, moving on again, I'm going to fill in 1 to the 9th is 1, and then 4 to the 9th is 262,144, and 1 minus 1/4 is 3/4. Okay. Another way I can think about this, do a little bit of math here, is I am going to make this into the same denominator as that, which is just going to be 262,144 over 262,144. That's going to be 262,144 over itself minus 1 over 262,144. And I'm going to put the 5/4 back here, and that's being divided by 3/4. When you divide by a fraction, you flip and multiply by the reciprocal. I'm going to go ahead and combine that to be 262,143 over 262,144 times 5/4 times 4/3. Okay, that allows me to cancel these fourths. And 3 actually goes into 262,143. 87,381 times. These are ones. I'm going to take 87,381 times 5, and I'm going to get 436,905 divided by 262,144, and that is my sum. I didn't include it, but there is a problem that asks for the sum of an infinite series all the way up to infinity of k equals 1, -3 to the k. And the rule about infinite series is if the absolute value of r is greater than or equal to 1, there is no sum. What that means is this is getting bigger and bigger without bound. It's getting closer to infinity, so there's not going to be a number that it goes to. But if it's going smaller, it's going to actually finally end. Thanks for watching. I hope this was helpful.